My name is Gary Johansson. I'm the VP of Quality and Regulatory at Matrix Tooling, Matrix Plastic Products in Wooddale, Illinois. Today I'm going to explain the CSS process, cross-sectional scanning. It's the newest, latest in inspection techniques. The part we're going to be looking at is the trigger. It's a medical device. We're taking the parts and setting them in a position that will give us the most surface scan. Then we place those in a container and pour the epoxy slowly into the container, keeping the bubbles and turbulation to a minimum. What you're seeing is 5 times actual speed. It's really a very slow pour in order to get the consistency that we want. But to make sure that we don't have any bubbles or voids in our epoxy cast, we'll take this part and place it into a compression vacuum chamber that takes the parts up to 50 psi and down to a -30. Our hardened epoxy block is then put on a aluminum plate and staged on the machine, and we set our cutter parameters, our speeds and feeds, if you will, and also the amount of product that we're removing at any one time, anywhere from 1 thou per cut to 10 thou per cut. The shallower the cut, the more data that you will gather throughout the whole process. So as the part moves across the cutter, the stock is removed and a little more of the part is revealed, and the scanner actually picks that data up and stores it. As the cutter moves across the part and removes stock, it reveals more of the surface. The 8-line scanner picks up that surface and sends the data to the computer for storage. Later on, we'll take that data and convert it from images to pixels and to points that can be inspected. So what you're seeing now is more and more of the part being cut away and data sent to the computer. Once the data has been transferred from pictures to pixels and finally to points, we have what's called a point cloud image. And as you can see, we're zooming in, we have hundreds of thousands of points that create the actual point cloud model. And we have our cutter depth was 2 thousandths per pass, and you can see. And each one of those points represents data from the actual part. We then take that point cloud into a third-party software and merge it with the solid model. All the points are positioned to the solid model. We then can do a comparison of the point cloud to the solid model. We also have a spec check report capability where we can section through parts and inspect those parts The nice thing about having the capability of using our CSS machine is that we get very, very sharp and crisp lines, very much unlike having to saw through parts and warp and distortion and all kinds of stress relief going on. Our parts being suspended in epoxy gives us a very, very clean edge no matter where we pass through the part. Because the point cloud data is stored on a computer, the data is always accessible and can be recalled at any time. We can access that data and do additional inspections, collect additional data very quickly. No need to pull out historic parts and reset it.